Good morning, my name is Marlene Luckner. I'm the marketing manager from ccm+neu, and I wish you a warm welcome to our seminar about SimCenter, simulation and testing. As an innovative company, ACAM is supporting its customers since 1994, primarily in the areas of product development and manufacturing. ACAM offers integrated solutions that cover all phases of the product lifecycle. As top partner with the Smart Expert status from Siemens Digital Industries, we have round about 40 employees at 3 locations in Austria. And do not only offer the extensive portfolio for software and hardware from Siemens, on top we propose services from professionals who support you or can do the simulation and testing for you. ACAM and its subsidiary ACAM Engineering are the perfect combination between software and hardware and service provider. Today, Stefan Riebenbauer from ACAM Engineering will give you a short overview about Star CCM and chances for your business. He's an expert in this topic and we are honored to have him here. Please, Stefan, it's your turn.
Hello everyone and welcome to my presentation about SimCenter Star CCM. My name is Stefan Riebenbauer and I'm a simulation engineer at ACAM Engineering and your host for this session. Let me start by telling you a story about innovation to explain what we do and why we do it. Have a look at this. What a crazy geometry, you might think. Do you wonder what it is? Believe it or not, this shape is providing new levels of efficiency and performance that are hardly imaginable. It helps reduce manufacturing costs by 34%. It was developed 75% faster than the previous version, and it also brings 22% improvement in efficiency. What is this part? It's actually a component of the ventilation system of HP's new jet fusion printer, which was released earlier this year. HP wanted to ensure that this printer was equipped with the best ventilation system possible. Why? Because one of the challenges with 3D printing is heat. If you can't dissipate the heat fast enough, it limits your productivity in how fast you can put out components. HP wanted to find a better way to make this duct more efficient in cooling off the printer so that it can run faster. So they used simulation and took the part that you can see on the left, which was actually made up of 6 parts, and they reduced it down to one single part. And then you get this crazy looking shape because it was created through generative engineering and it is delivering new levels of efficiency and performance that are hardly imaginable. This type of innovation is not just for 3D printers. We are seeing it everywhere across industries and applications. And this is the kind of innovation we want our customers to achieve. We want to take what the future promises tomorrow and make it real for our customers today. In other words, help our customers make better design decisions today for tomorrow. One of the biggest challenges engineers face today is the explosion of complexity, while at the same time the pace of innovation is faster than ever. Avoiding complexity is not an option, because it means limiting your ability to innovate. You must turn that complexity into a competitive advantage. Those who can best manage and deal with complexity are the ones best positioned to drive innovation quicker than their competitors. It is clear that more and more companies are starting to realize that the benefits of using simulation far outweigh the startup costs, since it provides a fast and low-cost environment that allows engineers to not only tackle the innovation of complex products, but to consider hundreds, if not thousands, of trade-offs in design. And the analysts are telling us this as well. In a recent study by Aberdeen, companies were asked to ask what top actions they want to implement to improve product performance, and you see here that simulation is taking a front seat mentioned in 3 of the top 4 actions. Taking a closer look, 73% of respondents say that their top action to improve product performance is to use simulation earlier in development. But companies are also aware that the products they design are complex, with 49% of the respondents indicating that they now need to combine more physics into their simulations to increase the realism of their simulations. So the key to success is to use simulation to find trade-offs in design earlier in the development process without compromising on the accuracy of the simulations. At the end of the day, it will be the companies that understand that managing the complexity of products is the path towards innovation and competitive advantage. When companies evolve and implement a digital transformation, when they embrace the technology like simulation and digital twin, they won't just make their complex products better, but bring them to market faster and more cost-effectively. Let me show you the value our customers are able to achieve when they make simulation central in the product development process. Energy efficiency is the single biggest concern facing shipbuilders and operators. Marine industry companies want to reduce vessel operating costs while meeting carbon dioxide and nitrogen oxide emissions regulations. While fuel savings can be achieved by using modern streamlined hull designs that efficiently direct water flow around the vessel into the propeller, this scenario primarily applies to new ship designs. Most of the world's commercial trade shipping is dominated by older vessels that are designed without the benefit of computational fluid dynamics tools and sophisticated design exploration techniques. To help meet fuel economy and emission standard goals, companies often retrofit customized energy-saving devices to their older vessels, and Becker Marine Systems is such a company. One of the most successful energy-saving devices currently in operation is the ccm+neu duct power-saving device, which was initially developed for full-form, slower ships. Distributed by Becker Marine, the µ duct provides significant fuel savings at a given speed, or alternatively, allows a vessel to travel faster at a given power level. The key to the success of Becker Marine's product is that the particular shape of the duct that provides the most energy savings varies depending on the hull geometry and propeller. This was quite a complex problem to tackle. So what they've done is created a process using simulation where they calculate the flow field around the hull and propeller. Then they automatically explore the design space varying 40 design parameters to define the duct geometry. What they are able to achieve is a guaranteed 4.5% improvement in fuel savings delivered in 6 weeks. What does that mean? It approximately is 1,000 tons in annual CO2 reduction, or 6% in annual fuel savings, and $500,000 savings per year for each ship. Thus far, they have installed over 1,000 ducts for a fuel saving of over 500 million per year. This is the type of value one should hope to achieve with simulation. Complexity comes with innovation, so you need to have the ability to model the complexity in order to drive innovation quicker than your competitors. In this short animation, you can see the digital twin of a car with an internal combustion engine. Here, SimCenter Star CCM is used to predict the real-world behavior of thermal soak phenomena and assess the impact on engine, hot end, and components in the engine compartment. Unlike wind tunnel testing, the realistic inertia behavior of air is captured by the simulation when the vehicle comes to a stop. So, as simulations become more realistic, they often include thousands of complicated parts, making it challenging to prepare the geometry for the simulation and generate a computational mesh. Going from CAD to mesh has long been a bottleneck in the process. So SimCenter ccm has not only state-of-the-art meshing technologies, but also the most robust meshing technologies using a fully automated cut-to-mesh process, no matter how sophisticated your geometry is. It's something we are proud of, but also something critical to design exploration. As many design variants are simulated, you cannot have mesh failures or manual intervention. Nor you can be forced to oversimplify your problem just to accommodate meshing limitations. Our customers are telling us that when they use SimCenter ccm, they are able to achieve a 5 times speed up when working with geometries that have thousands of parts. SimCenter ccm delivers industry-leading CFD solutions to inform and guide your design process through every decision point across a wide range of industries and applications. But it is much more than a CFD code. SimCenter ccm is a best-in-class simulation tool that provides the most comprehensive set of physics models of any industrial CAE tool. The integrated multiphysics nature of SimCenter ccm eliminates the need to learn and connect multiple tools to enable physical phenomena and motion to be studied in a fully coupled manner, increasing the accuracy of your results. All this reduces approximation and thus gives confidence that the predicted behavior will match the real-world behavior of your product. We have created a comprehensive set of physics capabilities within SimCenter ccm so that you can accurately test your virtual prototypes. From fluid dynamics to conjugate heat transfer, multiphase, combustion, motion, and more. All interconnected, all within one tool, so that you can use the right physics for your engineering problem, whether straightforward or complex, and still easily explore the design space. SimCenter ccm serves a wide range of industries and applications. A broad range of validated models covers fluid dynamics, heat transfer, reacting flow, multiphase flow, particle flow, aeroacoustics, electromagnetics, rheology, and solid mechanics. For example, at Jaguar Land Rover, SimCenter ccm is central in the design process of all current and future vehicle programs. The challenge that they have is when producing luxury vehicles, passenger comfort is critical for their brand name. Jaguar Land Rover needs to bring new innovative ideas, maintaining the luxury brand quality to market quicker than their competitors while still being cost efficient. For the cabin design, JLR has turned to SimCenter ccm. The HVAC ducts are fully designed through simulation. With simulation, they look at acoustic noise, to de-ice defog performance, to thermal comfort during heat up or cool down modes. By using the digital twin for simulation, JLR is enabled to evaluate different design options quickly without cost of expensive hardware for testing. The first physical prototypes are used for verification and validation of the design process. And here is what they have to say about the solutions from Siemens.
In JLR, it's very important for us to be able to save costs, and prototypes can cost £200,000. If we can save a prototype, the software sort of paying for itself and the techniques are paying for themselves. So effectively, in JLR now, some techniques like the defrost system, the demist, we do not build any prototypes apart from the final prototype. So it relies totally on CAE, CFD techniques to model that.
Then there is Cordesa, which is a consulting company that develops a corrosion simulation tool chest for the materials community, and they have been instrumental in transitioning corrosion simulation analysis into the military and commercial design communities. Their methodologies and best practices have been influential in steering revised military standards. The NACE 2016 impact study estimates the global cost of corrosion to be $2.5 trillion, which is equivalent to 3.4% of the global gross domestic product. It is estimated that savings of 15 to 35% of this cost could be realized by implementing corrosion control and better design practices. Aerospace systems are greatly affected by corrosion. From teardown inspections, it has been found that more than 80% of aircraft structural failures are initiated from corrosion pits, many of which result from unintended galvanic interactions between a spectrum of materials, ranging from modern light alloys, traditional sacrificial surface coatings, and carbon fiber composites. Many design guidelines and standards do not effectively treat the kinetics of corrosion and furthermore simply do not have the data available on modern materials. As a result of US Navy R&D project, Cordesa has developed protocols for characterizing such materials data and has created electrochemical database, and they are using SimCenter Star CCM to solve the corrosion issues faced by complex aerospace systems. The impact is that millions of dollars can potentially be saved. Here is another business example. This shows how Siemens Gas and Power use SimCenter Star CCM to design hydrogen and natural gas burners using its comprehensive multiphysics modeling. The challenge is that using new fuels changes the dynamics of the flame in the system, which could lead to emergency shutdowns and, in the worst cases, catastrophic failure. SimCenter Gas and Power is able to accurately simulate flame position and combustion dynamics using SimCenter Star CCM, allowing them to design innovative gas turbines that produce lower emissions using new fuels. So Star CCM resulted in fewer expensive tests due to a better design, 5 times faster pre-processing going from CAD to mesh, and a 2 times faster simulation time. The overall project time is reduced from months to just a few weeks. For the last industry example, I have chosen Takeda Pharmaceutical. It is the largest pharmaceutical manufacturing company in Japan. Takeda has a focused world-class R&D innovation engine making an impact on patients' lives by translating science into life-changing medicines. The challenge that they had was when solid drugs are processed, segregation occurs due to different size particles behaving differently. To compensate for this, many times extra dosage is used, increasing the cost of the drug and the process. It was desired to find designs for the hopper that can reduce segregation. A few of the designs are shown on the bottom right of the slide. Experiments were carried out to characterize the material in order to use its correct properties in Star CCM's native discrete element method modeling capability. Once this was assured, various design configurations were 3D printed in lab. Simulations then showed and quantified the amount of segregation until a lowest segregating design was discovered. In the end, there was a threefold impact of the work. As a result of better design, segregation could be reduced and a savings up to 5% in drug substance can be achieved in large-scale manufacturing. It was achieved in a much shorter time using the digital twin approach in comparison to doing trial and error experiments. There were savings up to $1 million realized in the process development of this new design by reducing number of trials or experiments. But no matter how realistic your simulation is, the data it provides is useless if it does not influence the final design of your product. Simulation adds the most value to engineering development if it provides a constant stream of data that informs and guides the design process through every decision point. This is only possible when the simulation process is a robust and automated one, enabling you to quickly go from a single point simulation to running hundreds of simulations. If you look at where simulation engineers are spending most of their time during a project, you will typically find something like what you see on the slide right now. By far the most time they are spent is building a baseline model and running the first simulation. There you have too much manual interaction, lack of automation, complexity in connecting tools and setting up the process, and oversimplification of geometry or physics to make things work. so much time that once they get their first result, there is little time left to look at design variations to improve product performance before making a design decisions. Perhaps they can look at a handful of manual designs. What's required is a solution that is built with design exploration in mind so that it allows engineers to spend most of their time where they can extract the most value. Not on building and running the first model, but instead on exploring the design space to get the necessary insight to make better decisions much earlier in the design process. With such a process, you can go from looking at one to looking at hundreds or even thousands of designs and still meet your product deadlines. And you don't just have to take our word for it. This is what we are seeing in research studies by analysts as well. In a recent study, Tech Clarity asked best-in-class companies who use simulation where they spend the most of their time in the simulation process. Looking at this chart, almost 70% of time is spent before even getting to that first simulation. That's a lot of upfront time spent with little value extracted. Some of the bottlenecks mentioned in this report support what I stated earlier. There might be things you have experienced in your group as well. There were, for example, too much manual interaction or too many repetitive and tedious tasks that are very time-consuming, or the need to use multiple tools. So yeah, complexity in connecting tools and setting up the process is an issue, or oversimplification of geometry or physics to make things work. It is clear that in order to extract the most value from simulation, we must eliminate the bottlenecks that slow us down. So let me explain how this is achieved with SimCenter StarCCM. One of the things that StarCCM is well known for is bringing all the stages of the virtual prototyping process into one platform. In doing so, we have created not only a far better user experience with a single user interface and a single simulation file, but have completely automated and thus simplified the workflow from CAD all the way to the solution. This is achieved through a pipeline process which is robust and replayable with just a couple of clicks. So once you have set up your simulation, any design changes you want to make are automatically reflected. Our customers are finding that with this process, they are able to reduce their engineering time from setting up through analysis by up to 90%. But having an automated simulation process is not all that's needed. With SimCenter StarCCM, design exploration is also a fully integrated component of the platform, meaning the complexities of stringing multiple tools together are removed. If you know how to run a single simulation with SimCenter StarCCM, you can easily run hundreds as it leverages the all-in-one platform, automated meshing, pipeline workflow, and physics within SimCenter StarCCM to overcome the complexities that have historically prevented many from using CFD simulation in this manner. Our design exploration process is very different as it uses multiple search strategies simultaneously, and it dynamically adapts to the problem as it learns about the design space. What this means is that exploring the design space requires fewer iterations than other methods, and there is no need to be an expert or make decisions about which search strategy to use. All you need to do is specify the number of evaluations you want to conduct based on the time and budget you have, and then the intelligent search will make the decisions for you to get a better design. Let's listen to what Jeff Schlottmann has to say about SimCenter StarCCM.
The new technology that's been beneficial to us has been our ability to go from CAD to meshing to volume mesh. Essentially, it's effortless. Being able to set up your models, reading your CAD data, put on your boundary conditions, that has sped up our process quite a bit. We've been able to handle more analyses, to drive engine design, with the same amount of people because of the effectiveness we have with understanding the CAD data, understanding the meshing, and going right into the solving.
So yeah, this underlines what I've just said. And here is another real-world example from a Siemens customer, Airbus. So their challenge, they set out to improve the performance of the bleed air system on one of their aircraft. The system takes in both hot and cold bleed air from the engine and mixes that air before delivering it to the cabin air conditioning and wing ice protection system. The engineering problem at hand for Airbus was to redesign the mixing device in the bleed air system to ensure proper mixing of the incoming hot and cold air without introducing a large drop in pressure. They used a streamlined and automated process with SimCenter Star CCM, and this enabled them to explore the design space to get the necessary insight and design direction to innovate. For this example, after only 280 design variations, a solution was found that reduced temperature variations by over 90% while still maintaining the pressure drop constraint. And this was all an automated process. Yeah, so it's a straightforward concept, but using a modern process makes all the difference. In fact, in this case, Airbus initially attempted this problem by stringing together various tools in their toolbox, for example, preprocessor, solver, post-processor, and optimization, to look for design improvements around the baseline design. After 6 months, they got a result, but it did not provide the temperature uniformity desired, and the process was deemed too long, too cumbersome, too fragile to use in practice, so it was shelved. By using a streamlined process that is centered on design exploration, Airbus was able to overcome the roadblocks they faced. And moreover, because the process facilitates exploring design throughout the design space, they were able to achieve the goals and do it only in 10 days, start to finish. From 6 months down to 10 days with a far better solution, they truly were able to make better engineering decisions faster. Imagine what else they are now able to achieve with all this time left. So in this case, we are changing the design features of a subsea heat exchanger to improve its heat transfer performance while minimizing pressure drop in the system. Note the breadth of design parameters we are exploring here. For example, the heat exchanger height as well as a wide array of tube numbers and geometries. After 150 variations have been explored, we see that we have achieved a better design than we started. Over 30% improvement in cooling while meeting the required pressure constraint. Here is another example from Kawasaki Heavy Industries. Their challenge: gas turbines have higher efficiency when they operate at higher temperatures. But higher temperatures coming out of the combustor can scorch the first rows of the turbine blades. Moreover, to cool the blades, air is forced through their hollow interiors and out through cooling holes on their surface. But that cooling air is bled off the compressor, which reduces the machine efficiency. So GT companies desire to find the best trade-off between maximizing cooling efficiency while minimizing the coolant mass flow rate. Using SimCenter Star CCM in combination with heats, test hundreds of concepts to find better performing coolant channel geometry for the turbine blades on the L30A, already the world's most efficient in its 30 megawatt power class. A huge 200% improvement in turbine cooling effectiveness using an innovative cat ear-shaped duct. This process is enabling Kawasaki Heavy Industries to bring higher efficiency gas turbines to market, and that's faster. It's great to have an accurate model in your digital twin and have the ability to run hundreds of simulations to find trade-offs in design. But one important factor as well is to have the ability to run those simulations quickly enough to influence your design. A late simulation is not much better than no simulation. SimCenter Star CCM has been developed with parallel efficiency in mind. It is parallelized across the complete simulation pipeline, starting from the pre-processing through meshing, through the solution and into the post-processing, and it scales to over 100,000 cores. Of course, most people don't have 100,000 cores at their disposal, but by driving to scale at those levels, it means that when such a computer power becomes the industry standard, SimCenter Star CCM will able you to fully utilize these resources to get your results faster. We have been talking about running high fidelity simulations and running 100s of them simultaneously. And this, of course, also requires a rethink about how these simulations are run in order to make this possible. When analysis software is licensed on a core basis, you often end up with compute resources that are underutilized, restricting your engineering ambitions. Or you might find that your ambitions for design explorations are foiled by having insufficient licenses to simulate multiple design variations. SimCenter Star CCM offers a range of affordable and customizable license options to meet your simulation needs and throughput requirements. No matter the size or location of your compute resources or power licensing, our power licensing is designed to ensure that you can fully leverage your investment in our simulation technologies and maximize the value of your hardware. First, you can dramatically reduce turnaround time by running a simulation on as many cores as you like for a fixed price. Before, I mentioned that SimCenter Star CCM has scaled to over 100,000 cores. This can be done using a single license, and it's the very same license that an engineer sitting at a 16-core workstation might use. Same license, same price. You can also have complete flexibility for design exploration studies. We offer licensing that enables you to test any number of prototype variants within design exploration campaign concurrently, so at the same time, each on as many cores as needed based on your available resources. Additionally, license models are set up so you can deploy on cloud infrastructures if desired. These licensing strategies are all aimed at letting you affordably allocate computing resources to get the best overall throughput of virtual tests for your situation, so your engineers can focus on the engineering. So far, we have focused on product design, but you need to accelerate the pace of innovation in all areas, whether it's in design, manufacturing, IT process. All of these need a way to go faster, and that's not always easy to do. When you invest in Siemens Digital Industry Softwares, you're purchasing more than a world-class software. You get access to a team of support engineers and a whole community of experts whose mission is to proactively help you succeed. SimCenter Star CCM is part of a bigger portfolio of products called SimCenter, giving you access to an integrated solution for performance engineering that spans multiple domains, covers testing solutions, and blurs the boundaries between traditional standalone engineering domains such as electrical, mechanical, and systems. Here is the last example. It is of a company called VDL that uses several products from the SimCenter portfolio. More precisely, SimCenter Star CCM in combination with SimCenter Amesim. When thinking of switching to electric buses, the transition can sound very expensive at first. But at VDL, they found out that it can be even cheaper per kilometer to drive an electric bus than a diesel one. So we met Anouk Hall, aerodynamics and energy specialist at VDL, to discuss this new trend and the challenges that it brings with it. Energy management optimization is, of course, one of them. Yeah, so to summarize, first I talked about the importance of having access to a high-fidelity digital twin so that you can have confidence in your design decisions with a realistic representation of your product. I also explained how you can use SimCenter Star CCM to go from 1 to hundreds or thousands of designs and allow simulation to drive innovation. I covered how SimCenter Star CCM's solver technology, its parallel technologies and licensing tools allow you to make decisions in hours and not weeks. And of course, how SimCenter Star CCM is part of the SimCenter portfolio to accelerate your digital future. These enable us to transform what the future promises tomorrow and make it real for our customers today. So thank you for your attention. Here you have the contact information where you can get further information about ACAM and its portfolio. And yeah, thank you, and back to you, Marlene.